morning, all of you. In this session, I am going to explain about simple problems on design of longitudinal butt joints. This is the example for boiler. Here, this is a longitudinal joint. Okay, here this is a strap or cover plate. These are the rivets. Okay, in this session, I will explain how to design a longitudinal butt joint. Before going to the problems, first of all, you have to know the fundamentals about failures of a riveted joint. Rivet may fail in following 4 ways. First one, tearing of the plate at an edge. Okay, here you can observe tearing of the plate at an edge. Okay, for avoiding this failure, you have to provide proper margin. Okay, here M is the margin, M equal to 1.5 D. Okay, in second failure, this is the second type of failure, tearing of the plate across the row of rivets. Okay, here this is a second failure, tearing of the plate across the row of rivets. Okay, and this one is a third type of failure, that is a shearing of the rivets. Shearing of the rivets, you can observe here, this is the shearing of the rivet. And this is a fourth type of failure, that is the crushing of the plate or rivets. Okay, now the following are the important terms used for design of longitudinal butt joint. Here, let sigma t equal to permissible tensile stress induced in the plate material, induced in the boiler plate material. Okay, now sigma c is the permissible crushing stress for the plate material or rivet material. Tau is the shear stress, permissible shear stress induced in the rivets. Okay, now small d is the diameter of the rivet, capital D is the diameter of the boiler. Okay, small d is the diameter of the rivet, capital D is the diameter of the boiler. Small t equal to thickness of the plate, boiler shell thickness. Okay, small t is the thickness of the boiler shell thickness. P is the pitch of the rivets. M is the margin. Okay, the distance between the center of the rivet to the nearest edge of the plate is called margin. Okay, the distance between center of the rivet to the nearest edge of the plate is called margin. Okay, yeah, the margin value is 1.5 times the diameter of the rivet. It is a standard value. Okay, now pitch is the distance between two successive rivets. Okay, the distance between two successive rivets, center of the rivets, is called pitch. Okay, now this is the tearing strength or tearing resistance. Okay, yeah, PT is the tearing strength. PT equal to P minus D into T into sigma T. P is the pitch, D is the diameter of the rivet, T is the thickness of the plate, sigma T is the tensile stress induced in the plate material. Okay, and this is the crushing strength. PC is the crushing strength or crushing resistance, equal to N into D into T into sigma C. Okay, N is the number of rivets per pitch, and D is the diameter of the rivet, T is the thickness of the plate, sigma C is the compressive stress, compressive or crushing stress induced in the plate material or rivet material. Now this is a shearing strength. Shearing strength, PS is the shearing strength. For a single shear, for all type of lap joints, you have to consider single shear. For single shear, you have to consider this formula, PS equal to N into power 4 D square into tau. Tau is the shear stress, D is the diameter of the rivet. Okay, for single strap butt joints also, you have to consider single shear. Okay, single shear for all type of lap joints and single cover butt joints. Okay, For double cover butt joints, you have to consider double shear. Okay, here for all type of lap joints and the single cover strap joints, you have to consider single shear. For all type of double cover or double strap butt joints, you have to consider double shear. This is the formula for shearing strength. PS equal to 2 into N into pi by 4 d square into tau for double shear. Okay, double shear for double strap butt joints. Okay. In similar way, PS equal 1.875 into N into pi by 4 d square into tau for double shear for boiler joints. Okay. This one is the theoretical value. This one is the actual value for boilers. Okay. Now here N is the number of rivets per pitch. That means N equal 1 for single riveted lap or butt joint, N equal 2 for double riveted lap and butt joints, N equal 3 for triple riveted lap joint, N equal 4 for quarter full joint. Okay, like this. So N equal 1 for single riveted joint, N equal 2 for double riveted joint, N equal 3 for triple riveted joints. Okay. Okay, these all are the important formulas used in a design of longitudinal joint. Okay. For determining the efficiency of the joint, you have to use the following formula. Zeta is the efficiency of the riveted joint. Efficiency of the riveted joint equal to least value of tearing strength, shearing strength, and crushing strength divided by strength of the unriveted plate. Okay, here this one is the strength of the unriveted plate. P dash equal P into T into sigma T. Okay, so here PT is the tearing strength, PS is the shearing strength, PC is the crushing strength. Already we discussed earlier. Okay, so from PT, PS, PC formulas, you have to determine least value. Okay, okay, this is the efficiency for riveted joint. Now this is the formula for determine the suitable thickness of the boiler shell. T is the thickness of the boiler shell, and capital P is the, just consider P dash. Okay, now this is a P dash. P dash is the steam pressure or maximum inside pressure in the boiler. Okay, now capital D is the internal diameter of the boiler. Okay, capital D is the internal diameter of the boiler. P dash is the maximum inside pressure in the boiler. Sigma T is the tensile stress induced in the boiler material, sheet material, and zeta L is the joint efficiency, longitudinal joint efficiency. Okay, now 1 mm, this 1 mm for corrosion elements. Okay, so this is the formula for determining the suitable thickness of the boiler shell. Now for determining the diameter of the rivets, you have to use two formulas. First one, if the thickness of the boiler shell is greater than 8 mm. Okay, if the thickness of the boiler shell is greater than 8 mm, then you have to consider diameter of the rivet D equal to 6 root T. Okay, this is the formula for diameter of the rivet when thickness T is greater than 8 mm. If the thickness of the boiler shell is less than 8 mm, then you have to consider this formula, that is PS equal to PC. By equating these two values, you can get the value of diameter of the rivet. Already we know the formula for PC equal to N into D into T into sigma C, and PS equal to N into pi by 4 d square into tau for single shear, N into 2 into pi by 4 d square into tau for double shear, N into 1.875 into pi by 4 d square into tau for double shear boiler joints. Okay, so by equating these two equations, you can get the value of diameter of the rivet when thickness of the boiler shell is less than 8 mm. Okay, now this is the standard table for choosing the diameter of the rivet and rivet hole. For determining the pitch of the rivets, you have to equating these two values for determining the pitch of rivet. Okay, here PT is the tearing strength, PS is the shearing strength. Already we know the formulas PT, PS. From these two values, you have to determine pitch of the rivets P. Okay, So this is the tearing strength P minus D into T into sigma T and PS. Okay, already we discussed about these formulas. Now, after determining the pitch of the rivets, you have to check the maximum pitch of the rivets. P max equals C into T plus 41.28 mm. Here, capital C is the constant. Okay, this constant value you have to send from this table. Okay, so for single riveted lap joint, you have to consider this value. For single riveted butt joint, single strap butt joint, you have to consider this value. For single riveted double strap butt joint, you have to consider this value. And for double riveted lap joint, 2.62, double riveted single strap butt joint, 3.06, double riveted double strap butt joint, 3.50, like this. Okay. Now coming to the example problem. Design a double riveted butt joint with two cover plates for the longitudinal seam of a boiler shell, 1.5 meters in diameter, subjected to a steam pressure of 0.95 Newton per mm square. Assume joint efficiency as 75%. Allowable tensile stress in the plate 90 megapascal, compressive stress 140 megapascal, and shear stress in the rivet 56 megapascal. Okay, this is the given question. First of all, you have to identify the given data from the given question. So here first you have to observe the given riveted joint is a double riveted butt joint. So that is for double riveted joints, you have to consider n equal to 2. N equal to 2 for double riveted joints. Here two double riveted butt joint with two cover plates. That means a double riveted double strap butt joint. Okay, this is the diagram. Okay, this is the diagram for a double riveted double strap butt joint. Zigzag double strap double riveted joint for a chain. Okay, here the diameter of the boiler shell is 1.5 meters. That is capital D. Capital D equal diameter of the boiler shell, and this one is the pressure, maximum inside pressure P dash. Okay, and this one is the joint efficiency, that is zeta L, longitudinal joint efficiency zeta L, and this one is tensile stress, that is sigma T, and this one is compressive stress, that is sigma C, and this one is the shear stress, that one is tau equal to 56 megapascal. Okay, from the given question, the given details are internal diameter of the boiler shell equal to 1.5 meters, that is 1500 mm, and internal pressure equal to maximum inside pressure equal to P dash equal to 0.95 megapascal. Longitudinal joint efficiency equal to 75%, equal to 75 by 100 equal to 0.75, and tensile stress equal to 90 megapascal, 1 megapascal equal to 1 Newton per mm square, and sigma C is the compressive stress 140 megapascal, that is equal to 140 Newton per mm square, and maximum shear stress tau equal to 56 megapascal, that is equal to 56 Newton per mm square. Okay, these all are the given values. Now here n equal to 2 for double riveted joints. Okay, for double cover butt joints, you have to consider double shear. Okay, for double strap butt joints, you have to consider double shear. Okay, so in first step, you have to determine the suitable thickness of the boiler shell, that is a T, small t. Already we know the formula for boiler thickness. T equal to maximum inside pressure P dash into capital D by 2 into sigma T into zeta L. Here capital D is the diameter of the boiler, P dash is the maximum inside pressure, sigma T is the tensile stress, zeta L is the longitudinal joint efficiency. The answer is 11.6. That value equal to nearly, the rounded value is 12 mm. Okay, so this is the required thickness of the boiler shell. Okay, in second step you have to determine a suitable size of the diameter of a rivet. Okay, here the given the thickness of the boiler shell is 12 mm. That value is above 8 mm. Okay, if the thickness of the boiler shell is above 8 mm, then you have to consider a formula D equal to 6 root T. D is the diameter of the rivet. D equal to 6 root T. Substitute the value of T in this equation, you can get the value of diameter of a rivet. 20.8 mm is the answer for diameter of a rivet. But from standard table, you have to choose a standard size of rivet and rivet hole. Here, our answer is 20.8 mm. So, from this table, you have to select. Here, the nearest value is the rivet diameter is 20 mm. Okay, our answer is 20.8. Okay, 20 and 22 mm. These two are the nearest values. So here I selected this one. This one is the nearest value. 20 mm is the diameter of the rivet. That corresponding rivet hole diameter is 21 mm. Okay. Yes. Okay. I selected these two values for rivet diameter and rivet hole diameter. Okay. 20 mm is the rivet diameter. 21 is the rivet hole diameter. Okay. These are the preferred values. In third step, you have to determine the suitable pitch of the rivets. Already we know that the distance between two successive rivets is called pitch. Okay, here for determining the pitch of the rivets, you have to equating the tearing strength and shearing strength of the rivets. Already we know the formula for tearing strength, PT equal to P minus D into T into sigma T. Okay, so the tearing strength is 1080 into P minus 21 newtons, and the shearing strength is PS equal to N into 1.875 into 5 upon d squared tau. Here the given problem is double riveted double strap butt joint. So for double strap butt joints, you have to consider double shear. So that's why I am considering this one, double shear for boilers formula. Okay, now substitute all these values in this equation, you can get the value of shearing strength. PS equal to 72,745 newtons. Okay, now equating equation 1 and 2, you will get the value of pitch equal to 90 mm. Okay, so this one 90 mm is the pitch of the rivets. Minimum pitch is equal to 2 times the diameter, that is 2d. Minimum pitch P minimum equal to 2 into small d. And also you have to check the maximum pitch of the rivets. For determining the maximum pitch of the rivets, you have to use this formula. P max equal to maximum pitch of rivets equal to C into T plus 41.28 mm. C is the constant value. Okay, you have to select this constant value from the table. Okay, here from given question, the given problem, the given joint is double riveted, double strap butt joint. Okay, yeah, this one is a double riveted double strap butt joint. So the corresponding value is this one. For double riveted double strap butt joint, okay, the constant C is 3.5. okay, this one is C. So you have to substitute the value of C in this equation. Now T is the thickness of the shell. Okay, now P max equal to 84 mm. Okay, the maximum pitch of the rivet is 84 mm, but our answer is 90 mm. Okay, so always you have to select a small value. Okay, distance between rows of rivets, that means back pitch. Okay, here you can observe the distance between two successive rows of rivets is called back pitch. Okay, this is the formula for back pitch. Okay, So here the answer is 42 mm. The distance between two successive rows of rivets is 42 mm. And this one is the thickness of the butt straps, T2. T2 is the thickness of the butt straps. Okay. And M is the margin. M equal 1.5D. Answer is 32 mm. Okay. Here you can observe this one is margin. This one also margin. Okay. For determining the efficiency of the joint, you have to determine tearing strength, shearing strength, and crushing strength. These are the formulas and the corresponding answers. This is the tearing strength value. This is the shearing strength value. This one is the crushing strength value. Okay. So this is the double shear. Okay. You have to consider double shear. For double strap butt joints, you have to consider double shear. Okay. So from these three values, you have to identify least value of PT, PS, PC. Yeah, the least value is 68,040. So the riveted joint may fail due to tearing of the plate across the row of rivets. Okay. Now you have to determine the P dash, that is the strength of the unriveted plate. P dash equal to P into T into sigma T. This is P dash. P dash equal to P into T into sigma T. P is the pitch, T is the thickness of the plate, sigma T is the tensile stress. Okay. Already we know the formula for efficiency. Efficiency equal to least value of PT, PS, PC divided by P dash. Okay. Now the joint efficiency is 75% for this longitudinal joint. Okay. This is the answer for this problem. Now coming to the another problem. A pressure vessel has an internal diameter of 1 meter and is to be subjected to an internal pressure of 2.75 Newton per mm square above the atmospheric pressure. Considering it as a thin cylinder and assuming efficiency of its riveted joint to be 79%. Calculate the plate thickness if the tensile stress in the material is not to exceed 88 megapascal. Design a longitudinal double riveted double strap butt joint with equal straps for this measure. The pitch of the rivets in the outer row is to be double the pitch in the inner row, and the zigzag riveting is proposed. The maximum allowable shear stress in the rivets is 64 megapascal. You may assume that the rivets in double shear are 1.8 times stronger than in single shear, and the joint doesn't fail by crushing. Make a sketch of the joint showing all calculated values. Okay, calculate the efficiency of the joint. Okay, this is the given question. From the given question, first of all, you have to identify the given data. Here, first of all, you have to observe this is the diameter of the boiler shell, that is capital D. Internal diameter of the boiler shell, okay, capital D. D equal to 1 meter. Okay, and this one is the internal pressure, maximum inside pressure, that is capital P dash. Okay, and this one 79% is the joint efficiency, zeta L. Zeta L is the joint efficiency, longitudinal joint efficiency. And this one is the tensile stress, 88 megapascal, sigma T. Sigma T is the tensile stress. And you can observe shear stress, that is tau equal to 64 megapascal. Here the compressive stress is not given. Okay, here this problem also double riveted double strap butt joint. Okay, here you can observe design a longitudinal double riveted means n equal to 2 and double strap butt joint. For double strap butt joints, you have to consider double shear. Okay, so these are the given values. Diameter of the boiler shell D equal to 1 meter, that is 1000 mm. In maximum inside pressure 2.75 Newton per mm square, and longitudinal joint efficiency zeta L equal to 79%, equal to 0.79, and tensile stress sigma T equal to 88 megapascal, shear stress 64 megapascal. Compression stress or crushing stress is not given. Okay, here for double riveted joints, you have to consider n equal to 2. Okay, n equal to 2 for double riveted joints. Okay, so the given question is double riveted double strap butt joint. Okay, these two are the double riveted double strap butt joints. First one is chain riveted joint. Second one is zigzag riveted joint. So, okay, our given question is zigzag. Okay, so you have to consider this diagram. Okay, in first step, you have to determine the suitable thickness of the boiler shell. That is T. Already we know the formula for thickness of the boiler shell. Okay, this is the formula for boiler shell thickness. Substitute value of maximum inside pressure P and diameter of the shell. Okay, the answer is 21 mm. This is the thickness of the boiler shell. Now, in second step, you have to determine the suitable diameter of the rivet. Okay, here the thickness of the boiler shell is 21 mm. That is greater than the 8 mm. So you have to use diameter of the rivet D equals 6 root T. If the thickness of the boiler shell T is greater than 8 mm, then you have to use this formula. Okay, D equal to 6 root T. Okay, now our answer is 27.5 mm. You have to compare this value with the standard size. Okay, this is the standard size. Here the nearest value. Here our answer is 27.5 mm. So the nearest value is 27 and 30 mm is the nearest values. Okay, 27 mm and 30 mm are the rivet diameters. Here I selected this one as the nearest value. So the corresponding rivet hole diameter is 28.5 mm. Okay, so you have to select this value for standard sizes. Okay, 27 mm is the standard size rivet diameter. 28.5 mm is the corresponding rivet hole diameter. Okay, for determining the pitch of the rivets, you have to equating these two values. Okay, already we know the formula for tearing strength. Pt equal to P minus D into T into sigma T. The answer is 1848 into P minus 28.5 newtons. Okay, PS is the shearing strength. Our given question is double riveted, double strap butt joint. For double strap butt joints, you have to consider double shear. So this is the formula for double shear. Okay, PS equal to N into 1.8 into pi by 4 D square into tau. Here N is the triple riveted. Here from this equation, you can get the value of pitch P equal to 147.8 mm. For determining the maximum pitch of the rivets, you have to use this formula. The maximum pitch equal to C into T plus 41.28 mm. Okay, from this table, you have to consider this constant value C. Okay, for triple riveted, double strap butt joints, you have to consider 4.63. Okay, so the maximum pitch is 140 mm. Then after we have to determine the row pitch or back pitch. So already we know the formula for row pitch or back pitch. Now this is the thickness of the butt straps, T1. Okay, this is the answer for butt straps, 18 mm. Now margin M equal to 1.5D, okay, equal to 43 mm. Now already we know the formula for efficiency of the joint. Efficiency of the joint equal to least value of PT, PS and PC. Here the value of crushing stress is not given, so I am not considering the value of PC, that is crushing strength. Only we have the details of tensile stress and shearing stress. So you have to consider least value of PT or PS. Here the least value is 20. Here 2,06,050 is the least value. Okay, this is the tearing strength. This is the shearing strength. Okay. Yeah, this is the formula for strength of the unriveted joint. Okay. So efficiency of the joint equal least value of PT PS divided by strength of unriveted joint. Okay. So here the joint efficiency is 0.796. That means 79.6% is the joint efficiency. Okay. Since the efficiency of the joint design joint is more than the given efficiency, therefore the design is satisfactory. Okay. So this is the final answer for this second problem. Okay, friends. In next class, I will explain more problems on longitudinal joints and circumferential joints. Okay.